We're going to get into some nitty-gritty now with using fundamental identities to manipulate expressions. This lesson is going to take us through a few of the techniques that are very helpful with these fundamental identities to change one trig expression into another that is equivalent. This is a very helpful concept in calculus as it often takes a problem that would be very difficult and turns it into a much simpler problem. So here we go. Our first technique is to use factoring. So we're going to try factoring the expression. For my first expression here, if you recall, the first thing you're always supposed to check for when you're factoring is a greatest common factor. So I see that there are two terms here. There's a secant squared alpha and a tangent squared alpha secant squared alpha. And those two terms have a secant squared alpha in common. So I'm going to take out a secant squared alpha as a common factor. So then I have to figure out what belongs in the parentheses. So what times secant squared of alpha would give me secant squared of alpha, that first term. That would just be a 1. And then what times secant squared of alpha would give me tangent squared alpha secant squared alpha. Well, that would be tangent squared alpha. Now once I've got it factored, I may find that some of the identities that I'm familiar with already can now be applied. Like I know that 1 plus tangent squared of alpha is the same as secant squared of alpha. So now I could rewrite this as secant squared of alpha times secant squared of alpha. And much like when I'm just multiplying, say, an x squared by an x squared, I would get an x to the 4th. The same thing happens with your trig functions there. So if you got a secant squared of an angle times a secant squared of that same angle again, you could put those together and you get secant to the 4th of alpha. That's as simple as I can make that one. How you know you're finished when you're actually using one of these in a problem to try to simplify it is you would actually be looking for other techniques that you could use that would make that particular trig function that you're using easier. I could have taken a different route on this one, and instead of changing the 1 plus tangent squared of alpha into secant squared, I could have also replaced the secant squared of alpha with 1 plus tangent squared. That would have given me 1 plus tangent squared of alpha quantity squared. So in some instances, that might have been the easier thing to work with. Now you try this second example here. Remember, you're going to factor and then look for fundamental identities that you can apply to it, and then answer the question on the Google form.